Welcome to the lecture series of probability and random processes. Today we are going to see some problems under continuous random variables. Look at the question. A continuous random variable capital X that can assume any value between x equal to 2 and x equal to 5 has a density function given by f of x is equal to k into 1 plus x. Find p of x less than 4. So, given random variable is a continuous random variable, it takes the value in the interval 2 to 5, okay, x equal to 2 to x equal to 5, and the density function is given f of x is equal to k into 1 plus x. We are going to find the value of p of x less than 4. In the density function, one unknown value k is there. So, first we are going to find the value of k and back to the f of x substituting the k. Then only we are going to find p of x less than 4. In this question, it is given that a random variable has a density function. So, in this word itself we can identify that the random variable is a continuous random variable if suppose it is not given in the question. A random variable x, like that also the question can be asked. So, if it is the case, we can identify by the letter density function. From that we can identify that given random variable is a continuous random variable. So, now we will see the solution. We know the property for a probability density function. Okay. Solution, we know that integral minus infinity to plus infinity f of x dx equal to 1. So, using this property only we are going to find the value of k. Like this, in the discrete random variable we have done a problem. There was a value that is capital A. For that A we have used the same property for PMF sigma p of xi equal to 1. Based on that only we got the value of A in that discrete random variable case. So, here we are doing the continuous. See, whenever we are doing problems under two type of things, we have to compare each and everything, because then only we can remember the results very clearly. Okay. So, here continuous, so that we are using this result. Okay. So, it is given in the question x equal to 2 and x equal to 5. So, the actual interval is minus infinity to plus infinity. Only in place of 2 to 5 it has the value. So, in the remaining places it takes the value 0. So, the interval can be split at minus infinity to 2 to 5 and 5 to infinity. First and the last integral value 0. So, only we can take the integral 2 to 5. So, which implies integral 2 to 5 f of x dx equal to 1. Okay, f of x dx equal to 1. It is given that f of x is equal to k into 1 plus x. So, integral 2 to 5 k into 1 plus x dx equal to 1. We can take the k outside. Integral 2 to 5 1 plus x dx equal to 1. X dx in the form. Okay, this is of the form integral x dx. Integral x dx is x square by 2. So, based on that we can write this one as k into 1 plus x the whole square divided by 2. Okay, with the limit 2 to 5 equal to 1. So, this is of the form integral x dx, integration of x is x square by 2 with the limit 2 to 5. So, now we are going to apply the limit. Upper limit is 5 and the lower limit is 1. Okay. So, before applying the limit we can take the 2 also outside. So, k by 2 into limit for x only. So, 1 plus 5 the whole square minus 1 plus 2 the whole square equal to 1. Okay. So, which implies k by 2 into 1 plus 5 6, 6 square is 36 and 1 plus 2 is 3, 3 square is 9. So, 36 minus 9 equal to 1, which implies k by 2, into 36 minus 9, so 27 by 2 equal to 1. Okay, here it's 2 is there, so only 27. So, which implies k by 27 by 2 equal to 1. So, which implies k equal to 2 by 27. Okay. This 2 is here, so we need not to write it here. Okay. So, k equal to 2 by 27. So, now we got the answer for k. So back to our f of x, substituting our k value, then we are going to find the value of p of x less than 4. Okay. So the next one is p of x less than 4. So next we are going to find p of x less than 4. Actual interval is minus infinity to plus infinity. Here we are going to find the value for p of x less than 4. That means minus infinity to 4. So minus infinity to 4 f of x dx. This is what we are going to find. So in this question it's given that minus infinity, x equal to 2 and x equal to 5. Okay. Only in these two places the given random variable has value. So x equal to 2 and x equal to 5 means obviously x equal to 4 inside the interval only. So this can be splitted as minus infinity to 2 plus 2 to 4. Okay, is it clear? So in the first integral value is 0. Okay, only in the interval 2 to 4 the f of x value. So only 2 to 4. F of x is 2 by 27 into 1 plus x dx. So before integration we can take the 2 by 27 outside. This is of the form integral x dx. So 1 plus x the whole square by 2. Okay, you can consider the 1 plus x as a single term x with the limit 2 to 4. Before applying the limit we can cancel the 2 so that we can get 1 by 27 into limit for x alone. So 1 plus 4 the whole square minus upper limit minus lower limit is 2. So 1 plus 2 the whole square. 1 plus 4 means 5. 5 square is 25. So 1 by 27 into 25. 1 plus 2 means 3. 3 square is 9. So 25 minus 9. That means 16 by 27. So our p of x less than 4 answer is 16 by 27. Okay. So the next question is the amount of time in hours that a computer functions before breaking down is a continuous random variable with the probability density function given by f of x is equal to lambda e power minus x by 100 x greater than or equal to 0, 0 when x less than 0. What is the probability that a computer will function between 50 and 150 hours before breaking down? And the second one is it will function less than 500 hours. So the question is given random variable is a continuous random variable. It's given in the question itself. And also it's given that the amount of time in hours. So in the question what is given, the amount of time is in hours only. Okay. So the density function is given. Look at the density function, there is an unknown value, that is lambda is given. So first we are supposed to find the value of lambda, then only we can proceed the question. What is the first one? We have to find a computer will function between 50 and 150 hours. That means integral 50 to 150 we have to find. Okay, and here it is 500 hours, less than 500 hours. That means p of x less than 500 we have to find out. Here p of 50 less than x less than 150. These are the two things we are going to find. Before that we have to find the value of lambda. How we have to find the value lambda? Using the property of density function, integral minus infinity to plus infinity f of x dx equal to 1. Using that property we are going to find the value of lambda first. So look at the solution. We know that integral minus infinity to plus infinity f of x dx equal to 1. This is the property of PDF. So based on this property, integral, see here it's given in the question x greater than or equal to 0. Okay. So the actual interval is minus into plus infinity. Okay, actual interval is minus into plus infinity. In this question it's given that x greater than or equal to 0 only, it has a value lambda e power minus x by 100. X less than 0 the value is 0. Okay, so minus infinity to 0 the value of the function is 0. Only here only it is given that f of x. So this interval can be splitted as minus infinity to 0, okay, plus 0 to infinity equal to 1. The first integral value is 0. Okay. So 0 to infinity, given f of x, what is given? Lambda e power minus x by 100 dx equal to 1. Okay. Here lambda is unknown value, we can take outside. Lambda into integral 0 to infinity e power minus x by 100 dx equal to 1. Okay, e power minus ax, integration of e power minus ax dx. The result is e power minus ax by minus a. Okay, so based on that, it implies lambda into e power minus x by 100 divided by minus 1 by 100 with the limit 0 to infinity. Is it clear how we are integrating this? Okay, the next step, this 100 will come into the numerator. So it implies minus 100 lambda, okay, into e power minus x by 100 with the limit 0 to infinity equal to 1. Okay, next we are going to apply the limit. Limit is, upper limit is infinity and the lower limit is 0. So which is equal to minus, it implies minus 100 lambda into upper limit is infinity. So e power minus, okay, e power minus x by 100. So limit for x only. So this can be written as e power minus infinity minus lower limit is 0. Okay, so e power 0 equal to 1. Okay, e power minus infinity value is 0 and e power 0 is 1. So 1 by 1 is 1 only. E power minus 0 is also 1. So minus 100 lambda into 0 minus 1 equal to 1, which implies minus into minus plus 100 lambda equal to 1, which implies lambda equal to 1 by 100. Okay, we got the answer for lambda. Now we are going to do the subdivision. What is the first division in the question? See, a computer will function between 50 and 150 hours before breakdown. Okay, before breakdown the computer will function between 50 to 150 hours. So for that we are going to use a result. What is that result? We know that P of A less than x less than b. Okay, it is equal to integral a to b f of x dx. So based on this result only we are going to do the subdivision. That is, first one is P of, first case 50 to 150 hours. Okay, so P of 50 less than x less than 150. Instead of a and b, 50 to 150. So 50 to 150 f of x dx. Okay, f of x dx, which is equal to integral 50 to 150, or f of x is lambda into, lambda is 1 by 100, lambda into e power minus x by 100 dx. Okay, so here this 1 by 100 is a constant, so we can take outside. Before integration we can take the 1 by 100 outside. So integral 50 to 150 e power minus x by 100 into dx. Just now we have integrated the same term. So 1 by 100 into e power minus x by 100 divided by minus 1 by 100. Okay, so this 1 by 100 will come into the numerator. So 100 and this 100 will be cancel off. Only we can have a minus outside of the bracket. So e with the limit 50 to 150. Okay, so this 100 and 100 will cancel off. We can take the minus outside. Limit for x only. So what will happen? E power minus 150 by 100 upper limit minus lower limit is e power minus 50 by 100. Okay, so which is equal to minus, we can cancel the 0 and e power minus can cancel by 5 table 3 times and 2 times, and here it is e power minus 1 by 2. Okay, using calculator we can get the answer for e power minus 3 by 2 and e power minus 1 by 2. If you don't have calculator you can leave up to this, or you can take the minus inside. Otherwise better using calculator, because the calculator is allowable only. So we can write the value. Okay, so 0. The value of the e power minus 3 by 2 is 0.6065. Okay, the calculator answer I am writing here, and the e power 0.2231. So it is equal to, if you are taking the minus inside, this can be written as e power minus half minus e power minus 3 by 2. So e power minus 1 by 2 answer is 0.6065 and e power minus 3 by 2 answer is 0.2231. So when you are subtracting these two, we can get the final answer as 0.3833. So this is for P of left hand side is P of 50 less than x less than 150. This is what the first part of the question. For the second part, what is the second part of the question? The computer will function less than 500 hours. Less than 500 hours means we have to find P of x. Okay, so we are going to find P of x less than 500. This is what in the question. So P of x less than a means what is the general result? 0 to a f of x dx, because the original limit is minus infinity to plus infinity, and according to the question it takes the value 0 x greater than or equal to 0. So we can get 0 to a. So according to this result, this can be written as integral 0 to 500 f of x dx. So which is equal to 0 to 500. What is our f of x? 1 by 100 e power minus x by 100 into dx. So we can take the 1 by 100 outside. 0 to 500 e power minus x by 100 into dx. Okay, integration of this is 1 by 100. Same integration again and again we are repeating. Okay, e power minus x by 100 minus 1 by 100 with the limit 0 to 50. This 100 and 100 will cancel off. We can get only minus outside. E power minus upper limit is 500. Okay, so 500 by 100 minus lower limit is 0. Okay, so e power minus 0. We can cancel these two. Okay, so minus, we can minus e power minus 5 minus e power minus 0. If you are taking the minus inside, this can be written as e power minus 0 minus e power minus 5. So using calculator, e power minus 0, that is 1 minus, actually e power 0 value is 1, so 1 by 1 you can write it as 1 minus e power minus 5. Using calculator, e power minus 5 value is 0.0067. Okay, so the final answer is 0.993. Okay, so this is our P of x less than 500. This is the second part of the question. Hope you can understand this one. P of x less than a means original limit is minus infinity to plus infinity. Less than a means we can take only minus infinity to a. In this question it is given that greater than or equal to, look at the question. In the question it is given that x takes the value only in greater than or equal to 0. That is the reason why here we are taking less than 500 means 0 to 500. Or in between if you are taking 0, hope it is clear, 0 to 500. Okay, so 0 to 500 f of x value. Integrating this, we can get the final answer as P of x less than 500 answer is 0.9933. So this is the way we have to do problems under continuous random variable. Okay, when you are studying problems under the continuous and discrete simultaneously, better we have to compare the result at a time simultaneously, so that we can avoid the mistakes. Okay, thank you for watching.